Are we ready then? Let's go. Oh, right. Spiders that blend into the background very well.
I saw them.
Well, I was busy looking for blue and green chimera. Oh. So how's work?
Very good. I got the FPGA working,
Right.
which is delightful news.
Good. I'm glad. I don't know what it is, but I'm glad.
I'm sure we've spoken about it before.
Yeah, but that doesn't mean I remember what the acronym is.
Field Programmable Gate Array.
Oh, that thing that they gave you.
Yeah.
Yeah. Cool.
It now is an accurate simulation of our processor.
Nice. I sincerely hope none of this is breaking an NDA.
No.
Because that would be awkward. I've made a new instance.
I went into the L1 though, just for fun.
Yeah. Bit of nostalgia.
Yeah. It was lovely.
Yeah.
How was your work? No, you haven't been. No, you
I
have.
have been. I went back this Wednesday. Yeah, it was good. I mean, I got some stuff done. I've got some stuff to get done on Monday, so we're looking to move into version 1.0 at the start of February now.
Yeah.
Got pushed back a month because of various other considerations.
Other.
Yeah, it was security things that we needed to get fixed and stuff.
Yeah,
Sensitive
security is
data.
often a fairly low priority on teams, and then you find there's a gaping hole.
And yeah, we need to put a bit more on our database really, but we can get around to that when we need to. I still need to tidy up the file system. It's got a bunch of test files in there that are just cluttering it up. I always feel really, really dumb when we talk about work.
Why?
Because you're designing chips and shit, and I'm making websites.
To the casual observer, they're equally hard.
Yes, but to someone who knows what they're doing, like us, they're not.
They're just different. I mean, there's a lot more training and a lot more. I don't know. You know, it is just different.
I would disagree.
Yeah, but there's nothing like.
Like you've made a website, right? It doesn't look exactly pretty. It doesn't have any great functionality in it, but it works. It does the job, and it's up and it's working.
Okay, but if I taught you the fundamental principles and everything, you would be able to make a chip. It wouldn't necessarily be pretty. It wouldn't necessarily do lots of exciting things, but I bet you could make one that would do something really simple.
I feel like the issue here is, like the difference is, you made that website without needing someone else to tell you how, necessarily, because, I mean, fuck, you taught yourself VBA in, like, year 7 or some shit. I don't even
Year 7, please.
Sorry?
Before year 7, please.
I don't remember, okay? It's been a long time.
That was VBA.
I haven't actually procced him. Whereas I would need someone who knows what they're doing to teach me how to do that. I don't think I could, like, go on the internet and learn that.
What, VBA?
No, making a chip.
Oh, making a chip. Yeah. Well, the thing is, like, a lot of people assume making a chip involves, like, actually looking at a circuit diagram and actually knowing what the fuck's going on, but it actually genuinely doesn't.
No, I'm aware of that.
Nowadays we have programming languages which compile to circuits, so I literally just type out an explanation in a programming language of what I would like the chip to do, and the synthesizer does all the magic of picking resistors.
Fair enough. Oh god, are you
so ultimately it is just programming in Verilog. So if you learn the language Verilog and program in it, and press the synthesizer...
What are the properties of the language?
Very similar to C.
Right, I'm not good at C yet, so... That's
well, yeah, but... You know, it is a language.
Yes, I'm guessing functional.
Not functional. No. Imperative. I mean.
Imperative.
Imperative. C is imperative.
Right.
That's the one way, like, you say do this, then do this. Functional is like everything is a function. I don't know.
Well, functional is the same but abstracted, surely.
Because
you're saying do this, then do this, then do this, and this is what that.
No, technically, in a pure functional language, you cannot say do this. In a pure functional language, there is no command. There are no commands. There is nothing that modifies state in a functional language.
Well, surely there must be, or you'd never get anything done.
Well, yes, indeed. That's the problem with functional languages. Haskell is a pure functional language. How it does it, it expresses... your program is a function that describes what you would like to happen, and then they just magically have it that...
Oh yeah, but describing what you would like it to do is just telling it what to do.
No, it actually isn't. Like, so you say, like, you describe an operation that one could perform on a database. And then they just arrange it so that that operation happens at the end of the program. But it's not the same as actually doing the things. Like, there is a big difference. Like,
it doesn't sound like there is.
Mm.
On one hand, you're telling a thing what to do. On the other hand, you're telling a thing how you want a thing to be done.
Yeah.
Those are the same.
Okay, well, if you ever use a functional language, you'll notice the difference.
Well, I write in JavaScript, which is normally a functional language.
No, it's imperative. You're mixing up the words. It's an imperative.
Everything I've ever looked up about it, and believe me, in the last year and a half, 2 years, I've looked up a lot about it, it's all been said it's functional.
Just because it has functions doesn't make it functional.
No, I'm aware of that, because shit like Java has functions, and C# has functions.
And they're imperative, yeah.
Well, and also object-oriented.
Yeah.
But at some point in the program, you have to tell it what you want it to do.
The point is that's outside the language in something like Haskell, which is a pure functional language.
I still don't understand
like, things
how
happening. Like, it's perfectly valid to execute a functional program in any order, because what you ultimately get is an object which describes what you'd like to happen in a particular order, let's say, whereas in an imperative language, you have to execute it statement by statement, because it's telling you what to do where, like... Yeah. So if you want something to happen based on something else in a functional language, you have to express that as like some kind of weird object.
Right.
Whereas in... Are you full?
Yes.
I didn't even get one full load. That's amazing.
We'll get more then.
You sure?
Yeah.
Alright. Yeah, like, there's a difference.
Evidently. Well, it's beyond me, apparently. So, you know. And this is why I feel dumb.
But yeah, no, so the fundamental property of Verilog, which is interesting, is that all statements are executed simultaneously. Which is because it's hardware, and that's how hardware works. Like
yes, I see.
So if you write...
I mean, you could... Theoretically, they wouldn't necessarily be.
Yeah, okay, so what you do is you predicate everything. So you say, like, you can go, like, if this, then do this, otherwise then do this. But you've got to remember that those two, essentially, it'll just... What it ultimately translates into is, you know, a selecting circuit, which picks the result of... It executes both anyway, and then just picks the result or whatever. So...
Right.
But you don't really need to know that when you're using it. It's just like, if you do 2 assignments, you can't... The order will just be simultaneous, because...
Right.
Hardware.
Yeah. But, like, you could stagger it, I guess, theoretically.
Yeah, so what you do is... So you have you obviously have a clock in a circuit, which provides a pulse at a certain frequency.
Yeah.
So basically, you capture the results of each calculation at the clock pulse, okay?
Yeah.
So the code looks something like, at the positive edge of the clock,
yes.
X equals X plus 1, Y equals X times 3, blah, 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 blah.
Right.
Okay, and then at the positive edge of the clock, it will capture all those results. So basically, so if you use a variable, it uses the previous value, and then at the positive edge of the clock, the new value takes effect, essentially. So it's all done simultaneously at the positive edge of the clock, or the negative edge, or whatever you want to do.
Right.
So everything notionally happens simultaneously. Obviously, you're quite right. In practice, this is not true. And so then at the end of when you do a compile, what it will tell you is what the maximum clock frequency you can run the design at is. So it'll say like this design is valid up to 50 megahertz. If you go beyond that, God knows, heaven help you.
But also, you could, if you wanted to, for some reason, do it, I guess you could vary the processing time by the material through which it's processing.
Yes, in practice, it's very difficult to manufacture such a thing, I guess. So it's not be done. Some things do use asynchronous logic, which is where you don't have a clock at all, and basically you generate a valid signal. So when you know the answer is correct, you generate a valid signal.
Right.
And then that means that you can hand those to the next block. But Verilog doesn't cover that sort of thing. Verilog is just the clocks and
goodness.
Yeah. So you have two types of things. You have combinatorial logic, which is just like gates, bands, and ORs and whatnot in a circuit, and then you have clocks logic. So basically, the language you can say always comb, which means do this combinatorially, and then you go like x equals x plus 1. That would not be valid because you've used x in you can't combinatorially go x equals x plus 1 because that's just a looping circuit.
Right.
It doesn't make sense.
Yeah.
So that would be invalid.
Sure.
But you could certainly go x equals y plus 1 as long as y didn't depend on x. That makes sense. It's just saying that. And then if you want to do something like x equals x plus 1, you need to introduce the clock so that it actually happens at a given rate.
I think I just got a relatively expensive dagger.
Did you?
Well, maybe not. No, it's okay. I forgot to divide that by 2. Yeah, no, it's okay. It's not bad. It's got 190 DPS.
Right.
It's a fairway starting dagger, I think.
190 doesn't sound a lot.
Well, it's on a one-hander, you know.
Just gonna see what I can craft onto my gear.
Yeah.
But yeah, I think hardware is mostly just a mystery to people because it's so unusual. Hardly anyone. There are so few hardware engineers, and that is a real problem. So,
yeah.
I have absolutely no idea how you do that. I don't know how you do that, but actually, it is just programming in a programming language. Ultimately.
Yeah.
I think it's just mysterious rather than difficult necessarily.
I mean, if the development process has been abstracted that far in.
Oh God, yes, yeah. It's all the way up to x equals x plus 1. You can use multiply. That's fine. You can use a multiply, and that just implies a massive circuit.
But it does work.
Yeah. I can just do and in my code I do have x equals x times 15 or whatever. That just implies a massive circuit. I've got to be aware that the thing is you have to be slightly conscious of if I do put 5 multiplies in a row, the clock frequency will be 0.
Right, because it just
because a multiply circuit takes a long time to stabilize.
Yeah.
But then you can do weird stuff like say, I need the result of this multiply in 5 clock cycles time. So the tricky thing comes from when you try to make it go fast. It's easy to write the code.
Yes, it's tricky to optimize.
Yeah, very tricky to optimize because it's okay, when do I need this result? Actually, I don't need to know what the result of multiplication is for 5 cycles. So
I have been doing exactly the same thing on a much lower level, well, a much higher level, I guess.
A much higher level, yeah.
But on a much more simple level with PHP.